Hi, welcome to the second video of this CFG playlist. Now we will see parse tree. So a parse tree is the sequence of productions used to generate a string of words, often visualized as a derivation. Let's say we have a sentence, the man sleeps. So we can generate a parse tree for this sentence. So we have some production rules. From the I have taken this production rule from the previous video example. If you haven't watched the video, please play that video first. So we know that S consists of NP and VP. Later NP can be DT and NN, and VP later can be VI. So that's how we derive the sentence, the man sleeps. In the right hand side parse tree, we can see a bigger sentence, the man sleeps in the car. So we can guess that as your sentences get bigger, the parse tree will continue to grow. That means if you have a finite set of production rules, using those finite set of production rules, you can generate infinite set of strings. That means if your sentence are more bigger than this, like the man sleeps in the car yesterday when I was sleeping in my room, that means using same production rules you can generate more bigger sentence. So for a given context-free grammar, we have a set of valid derivation under the grammar, and this can be infinite. And the next thing is, if you have a sentence defined by the CFG for a particular language, this sentence must have at least one derivation. And some string in the language generated by the CFG may have more than one derivation, and this leads directly to the problem ambiguity. Let's see an example of ambiguity. We have a sentence. He drove down the street in the car. So for this sentence, we have a parse tree like this, and we have another parse tree like this, where in the bottom side we can see that we have a prepositional phrase in the car under the rule NP, and NP has the rule NP and PP. So the noun phrase is here, the street in the car. So the possible or highly impossible interpretation of this noun phrase is, the street is actually located in my car. So this cannot be possible in our inverse. This could be possible in parallel inverse, I don't know. So this is a possible but highly impossible interpretation. But in this parse tree, you can see that this prepositional phrase has a rule under this BP. So BP has VP and PP. So this PP prepositional phrase in the car is modifying this VP, drove down the street. So the interpretation of this parse tree is, someone is driving his car in the street. But the interpretation for this parse tree for this sentence is, in this parse tree is, someone is driving, but the street is actually located in his car. So there are many kind of ambiguity, like parts of speech ambiguity. Let's see here a word record. So this word can be noun, this word can be also verb. Here means verb intransitive or intransitive verb. So let's say we have a sentence, saw her record in the telescope. In the left hand side derivation of parse tree, the record is behaving as a noun, and in the right hand side derivation, the record is behaving as a verb. So in the left hand side derivation, the interpretation of this parse tree is, someone is seeing his record with the telescope. This record can be video record, audio record, or file record. Someone is seeing a record with the telescope. But in the right hand side derivation, the interpretation of this parse tree is, someone is recording something. That means like someone is breaking the record of making of doing 6 or something. or breaking the record of goals, or breaking the record in a Guinness or record where record is actually working as a verb. So we have another kind of ambiguity, which is noun pre-modifiers. So let's say we have a sentence, the first car. In the right hand side parse tree, this noun phrase mechanic, this noun mechanic is pre-modifying actually the noun first car. That interpretation of this parse tree is the mechanic is actually works in a first car. The speciality of this mechanic is first car, but in the left hand side derivation we can see the interpretation that this car mechanic is modifying this first, means this car mechanic is really fast for his job. So that's all from parse tree, and later we will see probability context free grammar.